And for the last part of the question, finally, we are asked to consider two more situations that could affect the strength of the signal detected here. So the first one asks us, what if the amplitude of the two waves is doubled? Okay, well, if we double the amplitude of these two waves, we also double the amplitude of the resultant wave, and we know that the intensity of a wave is directly proportional to its amplitude squared. So if we double the amplitude, we're going to multiply the intensity by 4. And this is the strength that we're measuring with our detector. So whatever number we had before, it's going to be 4 times bigger now. So this is 1 mark and this is 1 mark. And for the last part, what happens if we rotate the detector by 90 degrees around that axis? Okay, so here is OQ, that's our axis. So we've got to imagine turning that. So let's say our detector is vertical to start with. Then when we turn it about that axis, 90 degrees, then it'll end up horizontal. All right, all of this talk of turning detectors, hopefully that makes you think polarization. And this is the point where we need to point out that microwave transmitters emit polarized light. Now these things, they have a base to them and a handle on top, so we can assume that both of these have been sensibly put on their bases, and that means that both of these are going to have the same polarization. So if you set this up normally in the lab, they're both going to be the same way up, and they're going to have the same polarization. Okay, if your aerial has the same polarization as the waves, so let's say that they're polarized vertically. If our aerial is also vertical, then you're going to detect the maximum intensity. You're going to get the whole signal, and then as you turn it, it's going to get less and less and less, and then when it gets to 90 degrees, now you're not going to detect any of this signal at all. This aerial is perpendicular to the polarization. You're not going to detect any signal at all. So that's what's happening here. So for the first mark, you can say that the waves emitted by the microwave transmitters are polarized. For the second mark, that means that as you rotate the aerial to 90 degrees, the signal will reduce to 0, and that's because then the aerial will be perpendicular to the polarization of the waves, and that gets you the 3 marks. Microwave questions can be awful because they've pulled together so many different parts of the waves topic. So I strongly encourage you to dig out every last microwave question you can and do the whole lot.